Hi, welcome back to Lewis in Chemistry. This is Lewis structure lesson number 4. Remember that Lewis structures represent the number of valence electrons around each atom in a compound structure. Also, it's important to remember that 2 dots equals a dash. These 2 dots equal 1 dash. Because in Lewis dot structure, we just use the dots. But in Lewis structure, we use both dots and dashes. Okay, let's look at our compound. Oxygen diiodide. Wow, that's a pretty big one there, huh? So, okay, we look at oxygen. It's in group 16, so we take the 1 out. So we're going to draw 6 electrons to this oxygen. Okay, it's looking pretty good there. Everything is going snarly. We hope it continues to go that way. All right. Let's look at iodine. Iodine is in group 17, so we have 7 valence electrons. Okay, so there's 7 valence electrons. Now let's do our electron valence count. Oxygen, we have 1 of those, and it brings 6 valence electrons to the compound. We have iodine. Iodine, we have 2 of those, and each one brings 7 valence electrons to the count. So when we do this, this gives me 6 valence electrons. This gives me 14 valence electrons. This gives me 20 valence electrons. Now, let's go ahead and draw the structure. And before we do that, we need to determine which one is the core atom. Well, obviously, it's going to be the oxygen because it has 2 docking ports. It means 2 single electrons. And iodine only has 1. Okay, so let's go ahead and do this. Go ahead and put our oxygen there. And we're going to go ahead and put a dot there, a dot there, a dot there, and a dot there. Well, now we're going to attach our eye. So we're going to put an eye here. And we're going to put an eye there. So let's go ahead and attach that. And then we're going to make sure that our wraparound atoms have their octets, right? So the dash gives us 2, this gives me 4, this gives me 6, and this gives me 8. Okay? This gives me 2, 4, 6, and then of course 8. All right, now let's see if this is the best possible structure. Well, we're going to use formal charge for that. Formal charge equals valence electrons minus non-bonding electrons minus bonding electron pairs. Okay, so the formal charge for oxygen is going to be, oxygen comes with 6 valence electrons, non-bonding electrons. Let's look at our structure. There are 4 dots there. So we have 4 of those, and we have 2 dashes, so we have 2 bonding pairs. So 6 minus 4 minus 2 is 0. Okay, the formal charge for iodine. Okay, iodine comes in with 7 valence electrons. All right, non-bonding electrons, count the dots around the eye, you get 6 of those. Which eye are we using? It doesn't really matter because they're all the same. And then it has 1 bonding pair. There you go. So 7 minus 6 minus 1 is 0. And that's it. That is the best possible structure. Now, there's something called hybridization. And if we want to talk about hybridization, we can. I can bring this up. I'm going to bring this up in later videos anyway. But when we look at the hybridized orbital for oxygen, and the hybridized orbital for iodine. let's go ahead and look at those real quickly. Now, it's important to remember when you hybridize orbitals, you're combining orbitals. So the only thing that count in hybridization are dots, like this, and dashes. So remember that S has one dash, right? P has 3 dashes. D has 5 dashes. And F has 7 dashes. Okay, these are suborbitals, is what they all are. Okay, now watch this. We have one for S. Okay, so this is S. And then we got 1, 2, 3. So this would be S, P, 3. If you count this, this is 1, 2, 3, and then we're going to make this number 4. Pretty cool, huh? So what about the I's? Well, let's count those. Dashes and dots, remember? So with the dots, we have 1, 2, 3, and then we're going to call that 4. So that is also going to be 1 for S, 3 for P. And that's the hybridized orbital for this particular compound. Well, that's it for this lesson, guys. You be snarly, and we'll see you back here at Mucine Chemistry.